So I'll explain what I mean. But so anyway, that's I'll give an introduction, then I'll talk about the trends accepted by mainstream scientists, and then implications for horticulture. So you can't read that at the top, but this is my agenda. I start with this slide so that you understand that this, for me, is about people. This is all about people. It's not about getting you to like Al Gore. Some people really dislike him, and I don't care if you do. I don't even think he's the best spokesperson on this topic. But it's not about political ideology or anything like that. It's just about the science and what it means for us people. Again, along the lines of introduction, the U.S. military, not just the U.S. Navy, the U.S. military has been working on climate change science for decades. So this is not something new to our military, and they know they need to understand what the science says to protect our troops and to understand where the hot spots in the world will be. So this is very much cutting edge stuff, not only in science but in the military. There are many, many, many industries that work on climate change and incorporate it into their business plan. In particular, the industry hugely, because they're all about ensuring risk, and they want to know what the risks are. So this is an example. Walmart and major retailers are paying attention to climate change, and in fact, Walmart intends to reduce 22 million tons of greenhouse gas emissions from their business, worldwide business, by just a couple of years, year and a half. So I'm sorry, 2.5. So this is a big deal for a lot of major industries. There are faith perspectives. All faiths have statements on climate change. If you're a particular faith, if you're not aware whether it does or not, you might be surprised that it does. Actually, many faith perspectives. And I also point this out: if a deeply held value for you is preserving way of life, which is probably something we all share, then climate change threatens that. So this is, I ask you to pay attention to this issue. At least keep an open mind to what the science may be saying. Again, shared values. I think we all share the values of wanting to leave a world behind that's as good or better than what we've experienced. Okay, thank you. So what I want to talk about here now is some of the science. And I know this stuff really quite well. I've actually been to 3 scientific conferences and read extensively for years on this topic. So I really do know it quite well, and really invite questions, even the tough ones, whatever you want. Okay. But I'm going to focus on a few climate trends that are accepted by mainstream scientists. And I stress that word mainstream because this is the situation with respect to climate change. There are surveys show that 97 to 98% of climate scientists agree with the fundamentals that I'm presenting. Okay, so I'm not out on a limb here in talking about this topic. There are some 2 to 3% that have doubts about the mainstream presentation or reject it entirely. So I can represent those too, and I can point you to those. My experience with those few is that their analyses, I just don't think they held up, and that's why we have the situation that you see depicted.
Are they Republican?
I don't ask that question. I don't ask that question. And here is an even more striking graphic. This was an analysis of peer-reviewed articles on climate change, and black is representing those that accept the fundamentals on climate change, and the red, it represents those that don't. And this is a really important slide. This is really important. There's this whole body of literature called peer-reviewed research journals, and some of you probably have experience with it, especially if you published your master's degree or something. Here's just an example. I'll pass it around. Blogs, websites, all those things, that's not what scientists look at. Real scientists like us, the thing that carries the most weight is peer-reviewed literature, which is reviewed by experts. It's a really interesting and grueling process to go getting something published because these experts will make sure that it's really good before it gets admitted into the journal. And if you look at peer-reviewed literature, and I have, it is very hard to find papers that reject the fundamentals. Now, the fundamentals don't mean that we must do X, Y, or Z. The fundamentals simply are, I'll tell you what they are, and then we'll look at some data. The fundamentals simply are that greenhouse gases are rapidly increasing, the Earth is warming, and that this will increase weather risk. Okay, those are the fundamentals. So let's look at some of those. This is from since the 1880. These are global temperatures. So again, we don't look at weather in Lexington or Kentucky. That's not the global pattern that we're paying attention to. We're paying attention to the long-term trends for the Earth. And these are 4 different data sets from all over the world. There is one more, but it actually matches these quite well. And what can we see in this analysis? First thing we can see, I think pretty clearly, is that that these data sets agree rather well. Okay, so there's some differences among the data sets in certain periods, but generally they overlap pretty well. Okay, so scientists do agree on global temperature measurements. The second thing we see is that they're going up. But the third thing we see is that there's a lot of sawtooth, a lot of variation there. Okay, so it's not a straight line. In other words, we don't necessarily expect that 2013 is going to be warmer than 2012 globally. But we can see that, and there's even a little bit of a sort of a variation that follows a curvature, right? So it's not going to all go up, but there's a trend there that's going up, and that's where we're at for the last 120 something years. Now that represents what I just showed represents since 1880. And this is a plot over the last 1,000 years, which includes global temperature measurements from ice cores, and that's a accepted technique of measuring Earth's temperature. And you can see that over the last 1,000 years, what is happening in the last 100 years or so is out of the range of what we see over the last 1,000 years. And this is true if you go back further and further. I'm not going to show you lots and lots of data slides, but we're outside the range of what has been normal over the last, how far back do you want to go? So you all live this stuff. I work in an office a lot of times. Okay, I do work outside sometimes, but you work outside all the time. So if you're 50 years old or older, you have to know that climate has changed. I think that it's hard not to know. But some of the quantitative measures of this are shown here, that the changes in the USDA plant hardiness zones, they're migrating north. You know this. Why are they migrating north? Why would they not migrate unless the Earth is warming? I mean, this is a clear manifestation of global temperature changes. The growing season has gotten longer. Am I right? I mean, you guys, corn farmers are planting earlier, they're harvesting later. You know the growing season. That's since 1890, and this is the departures from average, and you can see that if you go over the last 110 years or so, growing seasons have gotten longer by about 15 days here in the United States, on average, 15 days. That's a lot in just a short time. Heat waves have become more common in the U.S. We're not having one now, but certainly some parts of the U.S. are, and you just look at the data, that's the trend. Here's one that you may not realize, but intense rainfall events are increasing. So on average, rainfall is about the same, but if you look at the more intense rainfall episodes, they are increasing in importance, in frequency, I should say. And one reason I'm interested in this, as all really plant pathologists are worldwide, is that diseases are changing their distribution. And we're getting southern diseases that normally would have been limited by by cold temperatures in the winter are moving up north. And this is just one example of a bacterial wilt disease. Now that picture is not from Kentucky, but this is just an example. But the streaming out of the root, you see all the streaming of the bacteria, the millions of bacteria, that's from our diagnostic lab. And we never had this in this disease, southern bacterial wilt. We never had it in Kentucky until the last couple of years. So just an example of why it matters to plant pathologists. And the important thing is, I've just shown that the Earth is warming, and I can show you as much data as you want on that, but I'm not here to do a data dump. But there's the important point here too. The second important point is we have a scientific understanding why this is happening. And we really only have fundamentally one scientific understanding as to why this is all happening. And you all know it, okay? So when is a frost more likely to form? If you have the same conditions, 2 different nights, when is a frost more likely to form? Clear night. Yeah, you know why. And so it happens on a clear night. So what's going on with a clear night? Why is that more likely to have a frost? Exactly, right. The clouds are trapping the heat. So clouds, in a sense, in a physics sense, are acting like, not exactly like a greenhouse gas, but close enough for the purposes of this example. It's keeping clouds and trap the heat, and so do greenhouse gases or heat trapping gases. Does anybody have an example of a greenhouse gas? Does anybody know an example? Methane, that's a good one. Yeah, what else? Carbon dioxide, that's a really important one for your industry, yeah. And nitrous oxide is really important. And there's others, but those are 3 that relate to agriculture. So we're going to talk about those. So yeah, this is the only scientific explanation that we have that actually makes sense and that fits. So if we look at the concentrations of greenhouse gases over the last 2,000 years, and again, these values come from ice cores, which they're considered very reliable measurements of the atmospheric concentration of these heat-trapping gases. They've all gone up in the last 150 years or so, 200 years. They should. We're emitting these gases. I mean, I drove here. I produce greenhouse gases. I heat my house. I air condition my house. And methane, is coming out from various sources. If we didn't find these dramatic increases in these gases, we would have to question our science. And so there's this increase, and the physics of greenhouse gases was actually known in the 1850-ish period, 1850. These gases were known to trap heat. So that part of this science is not at all new. And the theory of global climate change was first proposed in 1896 by a Swedish scientist. So this is not fundamentally new science. So let's go back to this a little bit more on the science realm. So here are temperatures over the last 1,000 years. Here's the warming that we've experienced and that we have an explanation for. There is no other idea or concept that explains this. And so now let's look at what the computer models say. And it's very easy to dismiss computer models because they're not reality. And that's okay. It's important to understand they're not reality. But we all carry computer models in our pocket, most of us, right? So we do have trust in computer models. And so while we're going to keep a certain sense of skepticism about computer models are going through the same scientific process that anything else, like that Dr. Dunwell does, or Dr. Ingram does, or what I do. It's all the same scientific process. And what do the computer models say? This is what they say. So they're here. Okay. So what we see is that all the models, all the computer models that are published in peer-reviewed journals, are going up, and they're going up fast. Okay. The second thing they say is that there's this increased uncertainty. So we don't know if we'll be down here. We don't know if we'll be up here. We don't know if we'll be in between. And that's part of the issue. We really don't know what's going to happen. So if somebody says, "Oh, we don't know what's going to happen," that's right. It used to be that you could pass on more or less the same climate to your grandkids. You knew that they were going to live in more or less the same climate that you grew up in. Sure, with variation, weather, right? But those days appear to be gone. And this is where we're heading by the end of the century, somewhere in that range. And we don't know where it will be. But it's clearly well outside in this century if these models are correct. And again, they're all over the board because there's like 25, 30 different models. So we don't know which model will be exactly correct, but none of them are within the range of human civilization. None of these temperatures are in the range of human civilization any time in the last 12,000 years. So yeah, it is scary when the people talk about alarmists. It is worrisome. We can address the problem, and you are part of the solution. Okay, but we have to understand why climate scientists, they gray very fast. Some of them, just because it really is kind of worrisome. So the pace of climate disruption is really staggering geologically. It really is. And Yogi Berra, the future ain't what it used to be. We don't know quite what the future will be, but we think it's probably going to be very, very different. Aren't there a few scientists that dispute all this? Yes, I've said that. And I can point you to those scientists if you like. I read their work as much as I can stand, but usually it's some of it's very good and some of it's so full of flaws that I get tired of it. So they're outside of the mainstream. That's the point. So you can choose to follow any scientist you want, but I am paying attention to those that publish peer-reviewed papers, and they're just the pace. We don't know the pace of climate change. That's why we're all over the board. But the publications all point to it going up fast. So the key points accepted by mainstream scientists. One, warming is happening and will continue. And this is a point that I didn't understand at first when I started studying this topic. The impacts of CO2, especially CO2, are unstoppable. And they're essentially permanent. Permanent. I mean, thousands of years. That's what the research shows. So we're really changing the planet in a big way. And uncertainty remains around the rate of warming. We don't know how fast this will progress, but we have every indication that it's going up very fast. And warming is affecting the global climate, and therefore weather-related risk will increase. And so as producers, this is what I tell producers in grain production areas too. There's going to be more risk. There's going to be more variation in your production system. Now, I do want to talk about its relevance to horticulture, but let me ask for questions, comments, or concerns. Any doubts? Any doubts? Because I'm happy to entertain that.
I've noticed. I was watching Nova the other day, and they were studying how spruce trees take carbon out.
Right.
And they are now creating these clean sweepers in the model of, say, spruce trees that actually starts doing something about sucking this carbon out of the air and scrubbing the air clean. Have you heard anything about that?
Yeah, I don't.
Any like solutions outside of just basically trying to stop being a carbon-based society? Right. I mean.
Yeah. Well, I do want to stress I like my lifestyle. So like probably you and all your customers, I don't want to. I don't want to go back to living in caves. So I'm not about that. There are a lot of really, to me, the biggest issue is we have not come to terms with the science yet as a society globally. But I'd say we're a little bit worse here in the United States than most of the other Western democracies. That's a shame because I think there are lots and lots of really good solutions. One of them is, and I will explain this in more detail, you all in the green industry are part of the solution, and CO2, suck it right out of the air. But there are a lot of solutions that are creative. Some of them are debatable and cause controversy, but geez, maybe some of them will work. Like some of the most creative things, some of my scientist friends will disagree with this concept of geoengineering, but suppose that we could float orbiting reflectors to reduce sunlight onto Earth enough to counteract climate change. It's actually not that hard, apparently, or expensive. Suppose we could capture the CO2 that comes out of power plant stacks and drive it underground. That is actually feasible.
They're doing that now.
They're doing that experimentally, that's right. And there are lots and lots of solutions. It isn't, we don't want to give up our good lifestyle, and we want the same lifestyle for everybody in the world. So yeah, I think there are lots and lots of solutions that do not require that we give up our lifestyles, but we have to be willing to talk about those as a society and maybe put a little funding towards those. This doesn't affect my funding stream, by the way. I'm not here to seek funding. I don't get funding on climate change and don't want it, so that I don't ever have that conflict of interest. Any other questions or doubts? I will quickly say one, just to show you. I really, I know this gets real complex, but remember this, okay? The global temperatures. If you look right here, you could make the argument that global warming has stopped. Well, hasn't global warming stopped? And some people do, and their analyses are badly flawed, because that's the global surface temperature. If the heat, if during that 15-year period, if heat is increasing in the ocean, has global warming stopped? No, and it has increased in the ocean, especially the deep ocean. If during that 15-year period, ice throughout the world has continued to melt, has global warming stopped? No, because melting ice takes energy and heat energy to go into melt the glaciers and melt the ice sheets and so on. So if you just look at surface temperature, that's a little curvature blip. I mean, it's just like this. We get variation. Remember, we get variation. But has it stopped? No. The oceans are warming. The ice is melting. Global warming has not stopped. And there's no theoretical reason to think it will. There's no science to suggest that it will. Okay, so let me switch into implications for horticulture. So first of all, abrupt change in production is not going to happen by mid-century. I mean, sudden, dramatic. We're going to live through a time when the change is slow. Okay, and why do I say that? How do I have the confidence to say that? Because if you look at crop production, here's the U.S. corn meal. It has gone up and up and up and up and up. At some point, it'll start to level off, but we're not going to. I don't think we're not going to fall suddenly in crop production in the U.S. So that's good news. It's going to have, and especially because we're adapting to climate change already. A lot of science going into adaptation. This is the way I picture climate change. It's like creating a headwind on global agriculture. So, more and more it's pushing against us, and more we're going to have to work harder to do what we're doing, okay? But over time, it will reduce production eventually. But I don't think it's going to happen quickly enough for most of us. But it will progressively be noticeable. So in a way, this is good news for colleges of agriculture, I have to tell you, because it's pretty well recognized that investments in agriculture are more important than ever. If we're going to feed, the 9 billion people we're going to have in a few decades, we're going to need agriculture to do more. And so I think actually it's a good time to be an agricultural scientist, because we've got this major problem that we have to address. So breeding, there is a lot of breeding. Now this is a corn slide. I don't know what's going on in the landscape area, but in corn there's a lot of breeding for tolerance to heat and drought. The major seed companies do not go in front of growers and say, we're breeding for climate change, because some growers will get up and leave and don't talk about that. But if you say we're breeding for heat and drought, they're glad, and as we all are. So there's a lot of this going on, and they know why. The breeders at the seed companies are scientists too. They know why they're doing it, but they just don't talk about it in the terms of climate change. Okay, so let's go back to this one. Intense rainfall events are increasing. So that, again, I'm not talking about the average rain. I'm talking about the ones where the heaviest rainfall occurs. Those are increasing. So what is it? What does this mean? Well, you'll figure out what it means for you all over time. Better than I will. But But some of the things will relate to increased attention to soil erosion because of the heavier rainfalls that can result in soil erosion. And improving internal drainage as well will over time become more and more, make more and more sense. And then on the other extreme, see, the more extreme weather is what the prediction is for the theory. So that is, in other words, harder rainfalls and then harder droughts, and then harder rainfalls and harder droughts. And so, so that's preparing for drought will make sense. So more attention to irrigation. Again, my focus is more, really so far, more on the grain crops production, but I think some of these will fit to in your own industry. And more attention to soil conservation through building soil organic matter and conservation tillage in crops like that, like the grain crops, because better rooted plants are more tolerant of drought and will drain better when we get those heavy rainfalls. So soil conservation measures will help the planting adapt better to the progressive changes that are happening already. More diversified cropping systems. Again, the landscape industry maybe is already pretty diversified largely, but we foresee more buffered farming systems that are not so, just one crop, one variety for hundreds of acres, to be more buffered against the varying stresses that you can't predict from year to year in a climate change world. Okay, this is going to, I think, relate to you, what I'm about to say. It relates to all of agriculture on some level. First of all, total greenhouse gas emissions in the U.S. Agriculture has its piece, but there are some bigger ones, electricity and transportation. And, I'm glad for electricity. It's a blessing. So I'm not pointing fingers. I'm just showing you where the opportunities are to affect some changes. And agriculture is a smaller piece of the pie, but it is part of the pie. And so,
are we part of the transportation because we're driving our trucks out?
you know what? I assume that the transportation production in one part in the agriculture and transportation in another. What do you say about that, Dr. Ingram? About the question is, are we part of the transportation? Robert's asking. Okay. Okay. You haven't seen the report, so you don't know how they're making their calculations.
Trucking goods.
Right. Right. Yeah. 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 I'm not sure where the trucking goes. But so agriculture has its part. Now this is a different. We're kind of talking about farm gate. Farm gate, which is before transportation, right? So likely the transportation part is, anytime you move the product, it's going under transportation. Yeah. All right, so this is CO2. This is total of CO2 in the United States emissions, and non-CO2 is mostly methane. Somebody mentioned methane and nitrous oxide. And about half of that nitrous oxide component is sorry, I just want to make sure. Yeah, is from crop production, which is, a lot more than landscape. But I anticipate that over time, the use of nitrogen will eventually become an issue through, for I don't know what, government regulations, or conversely, maybe government payouts to use your nitrogen more efficiently. I have no idea. But the point is, nitrous oxide is a small piece of the big pie, and all the small pieces are probably going to get attention over the decades. So, if you do something to make better use of your nitrogen, you're not only saving yourself money, but you're saving, you're doing a little bit for your grandkids. You really are. Because if you use less nitrogen, you're emitting less nitrous oxide. So what is the only cost-effective way? I mean, geoengineering, anything else, what is the only cost-effective way to capture CO2 out of the atmosphere?
Plant trees.
Yeah. Trees or anything else?
Oh, yeah.
Or anything plants. Yeah. Yeah. You guys and gals, you are part of the solution. There's only one way. I've studied the literature on geoengineering and all that, and there's only one way to cost effectively, so far, capture CO2 or sequester CO2 out of the atmosphere. And that's what you're doing. Okay? This is, well, let me show you. Great. Okay, so plants. I love this phrase. Trees are CO2 sequestration machines. You know who said that? Dr. Ingram. That's his phrase. He's done a lot of work on the carbon footprint of landscape production, and very remarkably good work. Just very impressive stuff. Anyway, so trees are CO2 sequestration machines. This place is a CO2 magnet, and will continue to be as the plantings grow and mature. So, man. This is a big part of what I would be talking about if I were a landscaper. So, a few calculations. Offsetting auto emissions with trees. Okay? So it's a good news, bad news. Okay. So out of Dr. Ingram's work here, a 30-year-old red maple tree sequesters approximately 64 kilograms of CO2 per year. So it's got its little piece that it's sequestering out of the atmosphere. So how does that relate to something like a car? Well, a car, a typical passenger car, emits 5,100 kilograms per year. That's out of the EPA's database. And therefore, it takes about 80 red maples to offset one passenger vehicle. So there's good news, bad news. The good news is you guys are pulling CO2 out of the atmosphere. You are. And that is the good news. And that's a very big thing, because very few industries can claim that. Can't think of any others other than agriculture personally. But the bad news is it's going to take 80 red maples to offset one vehicle. So we're not going to reverse climate change just through agriculture and landscape management, but you are part of the solution and may become a bigger part. So anyway, I've already said this. Landscape plants help address climate change by sequestering carbon. There's a limit to how much we can do with landscape plants. But that's okay. We'll take what little bit we can get, and it's worth. And there's going into the soil too. Let's not forget that, through the roots. And so this kind of comes back to your point. Okay, so and really a point that Dr. Ingram has made. If consumers buy more local production of landscape plants, that's less transportation, therefore less CO2 emitted for that particular product. So it's another reason to buy local. It's a good reason to buy local. But, I've already mentioned this, building soil organic matter. If you're doing that anyway, you're helping to sequester carbon into the soil instead of in the atmosphere. So that's a good thing. You should brag on that. Climate change is not, on the whole, a good thing. On the whole, I think most scientists are concerned with monkeying with the global temperature. But there are going to be some benefits, and I think that wise people look for those opportunities. And in fact, Cornell University, their College of Agriculture has a document that talks about the challenges of climate change and the opportunities for growers. And so, maybe some growers will start using high tunnels and producing produce locally that survives the winter or grows during the winter, because if the winters are warming, we can do things we couldn't do 30 years ago. And maybe they'll make some money selling local produce or local transplants that might earlier than maybe would have been produced. So I don't know what those solutions will be. You guys and gals will figure that out. But there could be new opportunities. If we're going to go down this path, and we are going down this path, maybe you'll find ways to make some money at it too. So there are lots of easy ways to slow down climate disruption. I have these LED bulbs in my house. I ride my bike. I'm careful with this. And, you're probably doing some of these things too, some of you. And, riding a bike, not everybody can do because of the roads. But, there's some easy ways, really easy ways. But,
hey, Paul,
yeah.
On the easy ways,
yeah.
One thing we did was we put stickers on our chippers that say, do not idle, and we try to train the
Beautiful.
guys that, once you're finished chipping the branches up, don't let the chipper just sit there and run. Shut it down.
Right.
Save fuel, save air pollution, and then the same with all of our cars and our trucks. If we're letting our stuff idle, we need to get out of that habit.
Sure.
Shut it down.
That's a good point. Yeah, I actually have learned to, if I come up to a train, I turn it off. And then when I turn it on, I don't touch the gas. So there's no extra gas used to start it. Engine's already warm. So that, I save maybe 30 seconds or a minute. And every little bit counts. It's a way of, I like to think of it as a way of loving my grandkids.
And then that car's not putting out 50, 100, or
Exactly.
54 kilograms.
Exactly. It's less.
Less than the average.
Less than the average. Exactly. Yeah. So there's lots of easy ways that we can all reduce. And I'm not here to tell you what to do. You all decide. You all can decide. But I've got one more point that I like to bring up. But what if agriculture, forestry could actually fix climate disruption? What if you could fix it? And this is still a research topic, but I'm going to tell you something that is in the scientific world being looked at, and in other aspects is being looked at. So here we have electricity generation. It's a huge source of CO2. Now that smoke is not CO2. CO2 is colorless. But out of the stack is coming a lot of CO2. And again, we're glad for that because it gives us electricity. But what if there was a way to capture that CO2, right? And what if we're running that plant on biofuels? So biofuels are fuels that are produced from biological materials, plants. It could be landscape trees that have been that have been taken down, then chipped up. Could be. Why not? And we're running electricity plants off of biofuels. Well, that means we're running it off of something that sucked carbon dioxide out of the atmosphere. Now, okay, it's going back into the atmosphere. We know that, but we still recycled it, at least for one cycle, by using plants. Okay. Well, suppose they could capture that CO2 instead of going into the air, put it right into the ground. There is technology to do that. It's called carbon capture and storage. So let me say that again. We're running the power plants. Again, this is research, and it's being implemented on an experimental basis. So it's not actually commercial, but it could be soon. I don't know. We'll see. So you're running power plants based on a biofuel, which is a recycled carbon. Take it out of the atmosphere and put it into the plant, and then you're capturing the CO2 that comes out of the electricity generating station. You're putting it underground. That CO2 is gone now underground. That your plant captured. It's being researched, so maybe someday you will be actually able to turn this thing around. We'll see. So, I love this phrase. This is from a county agent. Maybe carbon will become a cash crop for Kentucky producers someday. Maybe you'll get paid to do this. I don't know. This is a phrase from Ray Pierre Humbert. He's a physicist at the University of Chicago, and he said, we're running an uncontrolled experiment with the Earth, and we have to live in the beaker. So yeah, that's kind of where we're at. Anyway, I'm glad to take questions. I don't know if I've left enough time for that, but yeah.
Can we go back to the last slide? Yeah, one more.
This one? Yeah.
Okay. What if we grow hemp? Does it take in the
CO2? Oh, absolutely.
And then you use it in biofuels or whatever. So that's what they're working on now.
Could be. Yeah.
So there you go.
Sure. The biofuels. When I talk about biofuels in this system, it's any biofuel, any biological. Plants being the source here, and so we're not going to get enough from animals. So yeah. So it could be hemp. I don't really know. I'm actually not working on this aspect But I read a paper on this topic, and I said, man, I got to tell producers about this. Yeah.
You're looking more serious to switchgrass, sugarcane.
Yeah, switchgrass. Again, I'm going to quickly run into the wall of my ignorance here. I'm not a biofuels expert, but you're right. Switchgrass is getting right now. A lot of biofuel is being produced by corn and biodiesel from soybeans. But they're called first generation biofuels, and the second generation of biofuels are sort of where the country and the world wants to go. And what are second generation biofuels? These are biofuels that are not high in starch or oil, like switchgrass. They're just high in cellulose. But they will ultimately, when we can manage those, they'll ultimately have many advantages. Yeah.
I don't know all the statistics. The little report I saw lately, I mean, as I say, in northern sugarcane, they're saying switchgrass. I mean, like they're counting switchgrass as
the biofuel. Yeah, again. More than him? Okay. I think the big difficulty with switchgrass or cellulosic materials is breaking down the cellulose, the cell walls of the plant. So my understanding is, and I'm going to just tell you right now, there may be something I don't know about the biofuels and switchgrass, but my understanding is right now digesting the cellulose in trees or in switchgrass or in in other like grasses I don't think it's commercially possible yet to turn it into simple sugars that are used in fermentation. But I could be wrong too, so I'd like to be wrong on that. I'd like to know that switchgrass is right around the corner. So could you maybe afterwards you could direct me to where you read that?
I think it was Modern Marvels.
Modern Marvels? Switchgrass? Okay.
Whole thing over biofuels.
Yeah.
They're supposedly crossing the genes of corn and switchgrass to make the leaves bigger, so it will be able to produce more for the biofuels. This is something that I've read. I might be totally wrong.
That's good. You guys, do you want to say something about the biofuels? Because it's not an area I'm very well read in.
There's a lot of work being done. As a matter of fact, in the Horticulture Department in the UK, set involved doing work on cellulose breakdown.
Okay.
So that putting materials or creating the genetics of switchgrass and others where it may be twice as efficient or twice as easy to get to alcohol from the cellulose. So there are bonds that create the cellulose that if they're in the right arrangement, it's easier to get the energy out of it. It's easier to get the alcohol out of the switchgrass. Tests in the laboratory show quite an increase in the efficiency of that extraction.
Aren't you growing Spanish or something?
It's switchgrass itself. We're also certain on the left.
Yeah.
I'm wondering if they have the ability, with the picture you were showing about capturing CO2 in the ground, do they have the ability to separate CO2 out from all the other potentially harmful chemicals and gases? And on that, once we put it in the ground, where does it go? Is
Right.
there concern for water quality?
Right. Again, I'll answer what I know about the carbon capture and storage. I don't know the chemistry of how it separates out the carbon dioxide from the rest, but my understanding is it is highly enriched for carbon dioxide. So what's going in the ground is carbon dioxide. My understanding too is that these would be particular special formations, geological formations. They're quite deep, so shouldn't pose a risk to groundwater. And they have to have certain features that allows it to stay there. One of the aspects of the research of the carbon capture and storage is there's several that I know are taking place, and one question that researchers ask is, will it stay down there? We think it will, but really will it? Can we look carefully at those questions? So your question is a good one, and it is being researched. I think the general thinking is that this is something that can be done, but I don't think all scientists are ready to agree with that statement. Was something else. Something else about what you had asked. I don't know if I answered it, but yeah. Did you?
One statement is that biofuels is recycling, so it's recycling the CO2 in the atmosphere. But when you take fossil fuels, you're adding to the pipe, the size of the pipe.
Right.
When you burn that in the atmosphere, because it's already been sequestered, of course, or whatever. So it is a place that's not impacting CO2. You bring it out, basically, you increase the size of the pipe in terms of the quantity of CO2 that's available.
Right, that's a good analogy. Yeah.
Another challenge, getting off the biofuel subject, another challenge that we see as arborists and horticulturalists is after we have these severe storms, big trees get knocked over, the media shows a tree on a house or a tree on a car. We get a bunch of phone calls, people want us to cut down perfectly good trees. And so we have to go out there and try to educate them to, hey, you've got options. You can prune this tree, you can cable this tree's going to be okay. And a lot of people say, no, I just want it out of here. And then we say, okay, well then, why don't you put back a new tree? And they say, no, I don't want a tree now. And so the challenge is there. Or if they do want a tree, they want a dogwood instead of an oak. And there's plenty of room to grow a big shade tree that'll take in more CO2. So I think if we all step up to the challenge to educate people that it is okay to grow a large tree, shade tree, or a large evergreen tree, a spruce, that will help with CO2. That's good. It's good to educate folks. They need to hear that from professionals like us. Then the nurserymen sell more trees. The landscapers plant more trees. The arborists prune more trees instead of removing them with their sharp tools. Everybody's happy. And I mean, it's a no-brainer. If somebody asks me, should I prune this tree or remove it, and it doesn't have decay, it's not going to uproot, I say prune it, of course. It's easy for me.
So leaving a large tree or planting a new tree is a way of loving my grandkids.
I love your grandkids.
Yeah.
I already love them.
Every time you prune that tree, you are loving them. So yeah.
When we have these big storms, we have a lot more trees falling on power lines.
Yeah.
And that creates a panic. People want a lot of trees cut down. That's another place to educate. One thing you can do is, the arborists sell this right tree in the right place. So if you put the big trees outside the power lines, you won't have so many falling on the power lines, and then people get so upset because that really takes the skill.
Good point. I think the one thing I try to stay far away from advocacy on this topic because I want you to focus on I want to focus on the science and let you all, as the public, decide what fits. But the one advocacy point I think I would make, it kind of relates to all the topic on biofuels and all that, is the importance of research on this. I don't do work on biofuels, so I can tell you that there's no conflict of interest. I think the more research we do on biofuels, the better, as a country and as a world. I don't work in energy production, so I have no conflicts of interest saying we should fund energy research, because there could be a way to capture energy from matter that we have not yet discovered. And wouldn't that be remarkable if there was another way? People look back in 50 years and say, you mean they didn't know about this technology? So that's the one thing I would argue for, is I think there's the way out of this mess is going to have to involve research, and I think there's a lot of need there for that. So I guess that's it. Thank you.
This video has been part of the University of Kentucky Nursery Crops web series. For more information on the topics discussed, please contact your county extension office.